Okay, guys. Sorry, delay. We're starting notes now. Example C is where your class left off on Friday. So, if you recall, we were looking at our shrinks, stretches, compressions, whatever you want to call them, horizontal and vertical. Remember, horizontal is a new aspect this year. Vertical we did in the past. Horizontal is the new part. So, A, it was just multiplied by 2, so we considered it a vertical stretch. B, we talked about, that's where we left off, because it's 0.4x is in parentheses, we talked about two different options. We talked about 4/10 being 2/5, so this is 2/5 times x, which is the same as x divided by 5/2. So that puts us in the horizontal scenario, horizontal stretch, because 5/2 is bigger than 1. Or if you just multiply it 0.16, that's a vertical shrink. Okay, so let's take that knowledge and let's look at C. Y equals 5x squared. Thoughts on the horizontal option, first of all?
I mean, would you just square it?
We'll talk about that option second.
That's the vertical.
That's going to end up being the vertical option.
Okay, so then do we just put, is this kind of where like it's 5/5 or something like that? Like we did the last one?
Well, so what is 5 as a fraction?
Or 5/, is it 5/1?
5/1, yes.
5/1.
So the idea that if this is 5/1, multiplying by 5 is going to be the same thing as dividing by...
Wait, what?
Multiplying by 5 or multiplying by 5/1
Okay.
is the same thing as dividing by
1.
the
1/5.
reciprocal,
Oh.
1/5.
Oh, yeah.
Remember, if normally, I'm going backwards. Normally we say if you divide by a fraction, you multiply by the reciprocal, yes? I'm just taking you backwards from that. And so the idea that this can be y equals x divided by 1/5. Whoops, I wrote that wrong. X divided by 1/5 quantity squared. If it's x divided by a number within the squared, that's our horizontal. And this becomes a horizontal what?
Shrink.
Yep, horizontal shrink by a factor of
1/5.
1/5.
So essentially, you just get it into a fraction if you can, and then just say, hey, this is what
And
it is.
that's the reciprocal.
Yeah.
Think about a fraction multiplying by the x is the reciprocal of that fraction dividing by the x. Now, I do want to talk more and think logically here. If we're horizontally shrinking something in, what's it going to do vertically?
Stretch.
It's going to stretch up, yes? Now, someone mentioned this earlier,
It was me.
okay? But the idea, what is, if it's 5x quantity squared, 5x times 5x is
25x squared.
25x squared. In that form, that shows the vertical stretch.
That's a big stretch.
And so that is a vertical stretch by a factor of 25.
You said you'd accept either on the test, or is there going to be like a quiz? Is there going to be like where?
I mean, I'll accept either unless it gives a specific situation of how they want it expressed.
Will there be like questions where you need to do both? Tell me like with the horizontal and vertical.
It could be.
Okay.
It'll probably be a situation where I accept either, as I said, unless it specifically suggests something. I think it'll be either or. Okay. One more in this section. D. Y equals 1/3 x squared.
We're gonna do the opposite. X something's like multiplying. Are we still gonna divide?
Nope.
Divide? No divide?
Nope. Just go straight for the answer.
Oh, it's the reciprocal of 1/3.
No.
No,
Vertical
it's
shrink
1/3.
by factor
It's
of
1/3. I'm trying.
Vertical shrink by a factor of 1/3.
I'm overthinking it.
Okay, listen. Yes, you are overthinking it. So listen. Okay, this is just a number times x squared. A number times x squared is what we were doing in algebra 2. It's just a vertical shrink or stretch. Okay, that's all I need there. It's when it's in the parentheses that we have to decide which way we want to handle it. Whether we go the horizontal and make it x divided by it, or whether we just multiply it out. So this one is just a vertical shrink by a factor of 1/3. Okay? So, something a little bit new there you have to watch out for. So just kind of beware. Okay, example 5. We're going to go a little farther with this, and we're going to look at finding equations when stretches and shrinks are involved. Now, the function f of x is defined to be f of x equals x cubed minus 16x. So that is your given f. Find the equations for the following non-rigid transformations of f of x. Okay, don't be thrown by the word non-rigid. That's just a way they use to describe these. So on part a vertical stretch by a factor of 3. How are we going to take f of x and do a vertical stretch by a factor of 3?
Would we have to put a 3 in front of everything? We just put a 3 in front of the x.
I don't know, you tell me.
Okay, well, I know for the x cubed, we're going to put a 3 is it in front of it. It would be, yeah.
Okay, so here's what I'm going to say. If you look back to the front side of the notes, to do a vertical stretch by a factor of 3, it's multiplying the function by 3.
Okay.
And so I'm going to think of it as taking a 3 to everything. I'm putting it, for my work steps, so to speak, I'm putting it as we're going to take that 3 and distribute. Okay? So when we actually write it out to give our answer, in other words, basically what is 3 times f of x, that becomes
3x cubed minus 48.
Okay. So 3x cubed minus 48x is what that vertical stretch by a factor of 3 is. And just go back to that chart on the front. Vertical stretch is just a number times it. Okay? Now, on part B, we got to talk horizontal. So a horizontal shrink by a factor of 1/2. Well, what's it show horizontal on the front side of our notes there?
Fraction.
Right, it's a fraction.
The f of x over c.
And it's going to be, if it's a horizontal shrink by a factor of 1/2, then I'm going to think of this as f of x divided by 1/2. Now, with that in mind, okay, x divided by 1/2. We can go the route of every place we see an x, we're replacing it with x divided by 1/2, which is just downright ugly. But what is, x divided by 1/2? X dividing by 1/2 is the same as doing what? It's the same as doing x times 2 over 1, which is multiplied by 2, which is 2x. So I'm going to suggest instead of replacing every x with an x over 1/2, is that we instead replace every x with an
2x.
2x. So my original problem was x cubed. So now it's going to be, instead of x raised to the power of 3,
It's 2x.
it's 2x raised to the power of 3 minus, it was 16 times x, now it's going to be 16 times
2x.
2x. So every place I saw an X, I'm replacing it with what is 2x now. Now we are going to go one more step here.
The 16 to 2x. Would you distribute that?
2x raised to the third. What is 2x raised to the third?
8x cubed.
8x to the third. Because 2 to the third is 8, x to the third. Minus, and that's just a 16 times 2x.
32.
16 times 2x is
32x.
32x.
That's your answer.
Okay? So when they ask you to perform a specific operation, vertical, you're just multiplying through. Horizontal, you're replacing the x with something. So it's a matter of figuring out what you're replacing it with.
So on a horizontal, you want to get it into a 2x or something in front of the x, typically.
Well, and it could be a fraction. It could be. It's just, this one was a shrink by a factor of 1/2, so it turned into a whole number to put in. So just depends.
Chill.
Okay, questions on that section? I'm sure that we can talk homework questions if we need to tomorrow. Okay, example 6. Combining transformations in order. So I mentioned on the front side of the notes on Friday that order can matter sometimes. Okay, the deeper we get into transformations, order can matter. Okay, whether you reflect it or stretch it first or move it first, it depends. So we're going to do 2 different parts here. In part A, the graph of y equals x squared undergoes the following transformations in this order. Find the equation of the graph that results. So I'm going to suggest we take y equals x squared and we apply each of these transformations in order and see what we end up with. Okay, so for instance, x squared, how do we show a horizontal shift 2 units to the right?
Minus 2.
Okay.
In parentheses, so it'll be like x minus 2 squared. In parentheses.
So to go to right, that's going to be a minus 2 in parentheses, so x minus 2. And where's the square go?
Outside. Outside.
Remember that square is outside of the parentheses. Now, take this equation that we're at. How do I show a vertical stretch by a factor of 3?
You would add it. Would you just multiply the 3 out front?
Multiply the 3 out in front. So now my equation is y equals 3 times
X minus 2 squared.
x minus 2 squared. So vertical stretch, remember that's just, I think it's c in these notes, c times the function. So just multiplying the function.
I don't have these right.
In some scenarios, you might want to distribute it. In this one, I don't want to distribute it because I'd have to square it out first. And then the third piece, a vertical translation 5 units up.
You just do the same problem before and then outside, just add, or at the end, just add +5.
Okay. 5 up is just a 5 added on at the end. So 3 parentheses x minus 2 quantity squared plus 5. There's your final equation for that order. Okay. Moving it up and down and a stretch, order matters there. Okay, so you have to be careful.
Will there ever be ones that contradict? Does that make sense?
What do you mean?
Like, one will tell you, like, move it 3 left, and the next one will be like, okay, or one of them later will be like, move it 5 right. If that makes sense.
They could.
Okay.
I don't remember what the homework is, but. Okay, part B. Now we're going to go in the opposite order. Okay,
5 units over.
so with that in mind, now start with this one first. How do we show 5 up on just the basic x squared?
Y equals x squared plus 5.
Y equals x squared plus 5. That's your step 1, yes?
See?
Okay.
Uno.
Now, step 2. a vertical stretch by a factor of 3.
It would be y equals
3x in parentheses and then squared. No. It'd be 3 and then in parentheses x squared and then out of that parentheses plus 5.
No?
Am I overthinking it?
squared plus 5. Shut up, Tyson.
Well, I'm not sure. So we're vertical stretching the equation as is.
Uh-huh.
So my equation's already moved up 5. The idea is the vertical stretch is on all of it. So I'm going to say 3 parentheses x squared plus 5. Okay.
Yeah, that's somewhat what I was.
So, I'm not sure I heard the exact answer in there,
It probably was.
ever, but the idea is because they're saying order specific. And I know a lot of times we just kind of loosely say, okay, these things need to happen and we just make it happen. But because they're specific about the order here, moving 5 up is going to change the y values on your graph. And so when you then go and stretch it, those values are going to grow even more. So that's what you have to be aware of there. Okay. And then the final piece. A horizontal shift
To the right.
2 to the right.
Are we doing parentheses and side of parentheses?
Yeah, you'll have 2
Okay,
sets of parentheses
okay.
in this one.
So then you're gonna do 3. I don't even want to try to say it. Can I write it? You're gonna do. Okay, I'll just go for
We
it.
got 3.
Parenthesis. And then you're gonna do x. Right? Am I thinking of? Or no, it would be another. Yeah, parenthesis. Yeah, and then x minus. Wait, we're going 2 to the right. Minus 2, and then parenthesis, and then square that, and then add the 5, and then finish your bracket.
And I know you said parenthesis twice, and you can do parentheses twice. There's nothing wrong with that. It just gets harder to read, doesn't it?
Very.
So if you see me throw in a bracket, I'm just doing it to show that, okay, those are kind of like my outside parentheses. Okay, now, we still have the same piece. The whole thing's being stretched.
Oh,
That right 2 has to go in on the x. Okay, it has to go in on the x. Now, keep in mind, left or right 2 is not going to affect your stretch because your a vertical stretch has to do with y values and it doesn't change your y values. Okay? So, just kind of a beware there. Be careful. And as we move into example 7, we're going to talk one more time about the difference of order here. Okay? So,
Geometrically.
one more. This one, we have a graph shown. Okay? The graph of y equals f of x is shown. Determine the graph of the function y equals 2 f of x plus 1 minus 3 by showing the effect of a sequence of transformations on the graph of y equals f of x. So basically, we have the original graph here. This little blue thing, right? Or it's blue on my paper. As you look at this graph up here, surely, can you see 3 different transformations that have to happen? Okay, there's a 2, a 1, and a 3. All of those numbers mean something in terms of this problem. So now it's a matter of applying them in a proper order. Okay, with that in mind, think about order here. Start closest to the x and work your way out is usually what we think of here. Okay, there are some pieces that can be flip-flopped around though too. Okay, so thoughts of what you want to do first maybe?
Are we thinking about the plus 1 here?
We can.
Let's think about the plus 1.
Okay. So he says the plus 1. What does the plus 1 tell us to do?
It's gonna say we're gonna go left 1 unit.
So the first thing, or there's 2 things we could think of first. Okay. The left one is what I would probably go first.
That's right.
Now, with that in mind, put your tick marks on. I think basically there's 4 tick marks each direction. if we're going left 1, I see 3 key points here. On the first graph, there's a point at -2, 0. There's a point at 0, 2. And there's a point at 4, 0. Those are the 3 points I would do whatever I need to do to. Okay? So, with that in mind, if I'm going to move left 1, -2, 0 is going to move over to -3, 0. 0, 2 is going to move over to
-1, 2.
-1, 2. And 4, 0 is going to move to
3, 0.
3, 0. Okay? With that in mind, it's a curve between these two and a straight line between those two.
Agreed.
I'm not sure mine looks great, but we're going to go with it.
That's all right.
Now, what else needs done here?
I personally see the 3 down. That's just me.
I have to disagree.
Okay, I see the 2F there.
Okay?
It was 50-50.
Here's what I'm going to say, is I'm going to go with the 2 next, and start with what's closest to x and work your way out. That -3 in my brain is the farthest thing from x. So that's going to be the last done. Okay? Now, with this in mind, so the 2 is like a 2f of x, and what does that 2 represent?
2 times the equation.
But what is it as a transformation?
Stretch.
It's a vertical stretch, yes?
Yeah, vert stretch.
Now, with this being a vertical stretch, here's what I'll say. And no one really questioned it, so I didn't worry about it. These 2 right here could be switched. In other words, we could have done the stretch first and then the left one. Your order's not going to matter between those 2. Okay? I'm not,
Don't worry.
So just kind of so you know.
Yep.
Okay. I'm going to put my 4 tick marks on in each way again. Okay.
Just
Now.
multiply everything by 2.
A vertical stretch. He says multiply everything by 2.
Everything.
Can we define what everything is?
Everything inside the parentheses.
I have to.
Okay, everything in general.
I want to take this graph.
The coordinate points.
The
What is
coordinate
stretching
points.
by a factor of 2?
Getting
X
taller.
or the Y values.
Y values.
If we're getting taller, if it's a vertical stretch,
I quit.
it's my y values that are changing, yes?
Yes, ma'am.
So we're going to multiply each of these y values by 2. Now, on my last graph, I was at -3, 0. My y value on -3, 0 is
Negative 3, 0, so 0.
0. When you multiply 0 by 2, it's still at
0.
0. Okay?
Yeah.
Now, this point is at -1, 2. If that point is at -1, 2, it's now going to be -1, 4. And then our other point was at 3, 0. That y value is 0 this time, so it's just going to stay at 3, 0. Again, we kind of have a curvature between the first 2 points, a straight line between the next 2 points. Okay? And the last piece we need to do is
Pull that thing down 3.
the -3.
3.
And the -3 is taking your graph down 3. Again, I'm going to put my 4 tick marks on each piece of my graph. Okay,
And just each point, take that X down 3.
I had a point that was at -3, 0. So if I move that down 3, I'm going to be
Yeah, -3. -3.
-3, -3. It's not that you have to label them. I was just trying to help.
Which
I had a point that was at -1, 4.
-1, 1.
So if I move that down 3, I'm at -1, 1.
Yeah.
And I had a point that was at 3, 0.
Take that thing, and you're gonna make that thing 3, -3.
And now I'm at 3, -3.
Get it?
Again,
-3.
a curve, a straight line is what it's supposed to look like. Okay? So just the backside here, we're trying to show that order matters. And you've got to really think that through. Okay. Page 131, 2 through 32 evens is due tomorrow. You got about 5 minutes.